So for this reaction, we're looking at delta G equals delta H minus T delta S. We're trying to figure out if this is spontaneous, favorable. Those are basically synonyms in this case. So if this is going to be favorable, delta G is going to have to be less than 0. In other words, negative. And so let's just plug in. That's, we're given this information. So delta H is equal to 17 kilojoules per mole. We want this to be in joules per mole because S is given to us in joules. So we're just multiplied by 1,000. The temperature is 25 degrees Celsius, but we need this in Kelvin. So add 273. That gives us 298 Kelvin. Pardon me. It doesn't look so good. Times delta S, which is going to be 65 joules, pardon me, per mole Kelvin. And so altogether, you plug this in, we're going to find a delta G, which is equal to negative 2370 joules per mole. That's less than 0. Negative, that's favorable. So, answers the first question. Now, what would happen if we increase, or I guess in this case, what would happen if we decrease the temperature? So if we decrease the temperature here, let's say this became 200, the total value of this second term is going to reduce. And it's this second term that is causing delta G to be negative. Because delta H, this is positive. It's not helping in any way to make delta G negative. It's this second term basically overpowering delta H in the sense that it's a larger value and it's negative here because we're subtracting a positive value. So if temperature gets reduced, this no longer plays as much for relevance in delta G, and then the reaction will become non-spontaneous since it'll become positive and it'll reflect the positive nature of delta H more. And so now, does that explain why enzymes lose their activity? Kind of. Honestly, I think this is beyond the scope of this question. Generally speaking, the activity of enzymes, if we're looking at like temperature versus activity, it's something like this where it slowly increases and then decreases hard. Generally speaking, that's because over here it gets denatured. But at lower temperatures, the protein doesn't get denatured. It's just lower temperatures related to lower rates. So honestly, this seems to be a little bit beyond it doesn't give us enough information. I guess you could say that it explains why, at lower temperatures, some reactions here that have a positive delta H and a positive delta S, which wouldn't be all reactions, but definitely a subset of them, then at low temperatures, they would lose their activities. And I guess that explains it in that sense, but not a great question in my opinion.